Hello, everyone. This is Matter Made Simple with Ms. Rodriguez, and today we're going over everything you need to know for the matter unit in high school chemistry. So, starting off with what we're going over today, and that is states of matter, classification of matter, as well as the properties and changes of matter. But what even is matter? Matter is anything that has mass and takes up space. Now, can you identify if these things fit that description? Is a pencil matter? Yes, it is. It has mass and takes up space. Is air matter? It does have mass, even though it's very light, and it does take up space. Think of a balloon. Is light matter? It is not. It doesn't matter how bright the room is. You don't require more room just because there's more light. So no, it is not matter. The law of conservation of mass and energy states that they can't be created or destroyed, only changed from one form to another. And that's a concept that we're going to keep going back to the entire year of chemistry. Now, mass, though, is not the same thing as weight, even though we use these words kind of interchangeably. Mass is the amount of matter, meaning how much stuff is there. Weight is how that mass is affected by gravity. So, for example, on Earth and on the moon, you would have the same mass, but how much you weigh would be different. You'd be lighter on the moon because there's less gravity. There are three states of matter, and that is solid, liquid, gas. When it comes to the shape of these matters, solids have a definite shape. Liquids and gas have an indefinite shape, meaning that when you change their container, they're going to change shape. When it comes to volume, solids and liquids both have definite volume. So if you change their container, they still take up the same amount of space. The only state of matter that is compressible are gases, and that has to do with their particles. So if you look at the particles, solids have very tightly packed particles. Liquids have a little bit more room to move. That's why they can change their shape. While gases are very, very far apart. In fact, a gas is mostly empty space. Because of these gaps between the gas particles, you can actually push the particles closer together, making them compressible. The most common examples for the different states are for H2O, right? Ice, water, and steam all still have the same chemical composition, two H's, one O, H2O. But depending on their state, we call them something else. Solid water is called ice, liquid water is water, and gaseous water can either be called steam or water vapors. But in all states, the chemical composition is still H2O. Matter can be broken up into different categories, but starting with the top, right? Anything that has mass and takes up space is matter. If it has a constant chemical composition and distinct properties, so they can't be separated by physical methods, it's considered a pure substance. The first pure substance is an element, and an element is when there's only one type. It can't be physically or chemically separated, and you can easily find them on the periodic table. An example of this would be carbon. And if we look at the particles here, there are only C's, no other letters, so no other elements. That's what makes it an element. Compounds are two or more elements chemically combined, and they can be separated, but only using chemical processes. An example of this would be water. So water is H2O, meaning it's made of hydrogen and oxygen, and they are chemically combined, which we show in this particle here, using those lines, which means that they are bonded. On the other side, so if it's not a pure substance, then it's got to be a mixture. Mixture is matter that contains two or more pure substances that are physically combined, which means that they can be physically separated. There are two types of mixtures. You have homogeneous mixtures, which have the same appearance and properties throughout, also called a solution. And you have heterogeneous mixtures, meaning that they're visibly different appearance throughout the mixture. Now, examples of this, so a homogeneous versus a heterogeneous, we like to say a sugar cookie is homogeneous right? If we look at the sugar cookie, we can't point to the sugar, we can't point to the eggs, we can't point to the flour. But if we look at a chocolate chip cookie, yes, we still can't see those things, but we can definitely see where the chocolate chips are. So there's something visibly different that we can point out. If you look at the particles, here we have NaCl with H, so a compound with an element. And for the heterogeneous, we have H2 and CO2. So again, element with a compound. The difference between them is that for the homogeneous, they're kind of mixed throughout, right? They're not separated. While in the heterogeneous, it's clear that there is a separation between the element and the compound. So it looks visibly different throughout. Now let's look at the example of a pencil, right? Between solid, liquid, gas, a pencil is a solid. If we look at all the different parts of a pencil, we can see that it's made up of a bunch of different things. So looking at the rubber eraser, that is a homogeneous mixture. It's a bunch of different things put together, but we can't point them out. It looks like one full solution. The aluminum ferrule, so aluminum is an element. You can find it on the periodic table. The paint, so even though paint in general is a heterogeneous mixture, the paint that's on the pencil is already dried up, so we can't see all the different parts. That's why I'm calling it homogeneous mixture. The wood of the pencil, you can still see the grains, and wood is made up of a bunch of different things, so it's a heterogeneous mixture. And lastly, you have the graphite lead at the bottom. So even though it's called lead, it's not lead Pb from the periodic table. Graphite is actually made from carbon, which is an element. Going on to properties and changes. So what is a property? A property is an attribute, quality, or characteristic of something, meaning it's something that matter has. Physical properties describe matter, while chemical properties, there has to be some sort of change to the matter in order for it to be observed. So for example, physical properties are things like color, melting point, size, volume, opacity, and length. So these are all things that could describe. Chemical properties are things like flammability, reactivity, rustability, acidity, toxicity. So for flammability, for example, we have to set it on fire in order for this property to be observed. There's different kinds of physical properties. You have qualitative versus quantitative. Qualitative are observable. That means we can detect these things with our senses. So color, size, state, taste. We can see, smell, hear these things. Quantitative means measurable. So we can measure it using some sort of tool. So things like melting point, density, volume, mass, right? I have to use a ruler or a scale in order to be able to measure these things. Intensive versus extensive properties. Intensive properties do not change with amount, while extensive does change with amount. So things that are intensive could be like color, boiling point, density, hardness, right? It doesn't matter if I have 1 diamond or 100 diamonds. The diamonds are still going to have the same hardness. Same thing with boiling point. It doesn't matter if I have a cup of water or a whole ocean of water. The boiling point for water is still 100 degrees Celsius. Extensive does change. So mass, volume, size, length, right? It matters if I have 1 pencil or 100 pencils. The mass of the pencils are going to change. Same thing with the size of the pile. Now, one property, which is density, does need to be talked about a little bit because it does have a formula, so something that you have to calculate. Density is the degree of compactness of the substance, and the formula for it is mass over volume. Now, can you identify for me, is density quantitative or qualitative? And is it intensive or extensive? Write your answers in the comments. Moving on to our changes. The difference between a physical change and a chemical change is physical change is matter changing form. And a lot of the times it's going to be reversible. A chemical change, on the other hand, is going to form something new. And a lot of the times, these are irreversible changes. Examples of physical changes include melting ice, boiling water, dissolving sugar, shredding paper, chopping wood, right? When we melt ice, we can get it back. Chemical change examples are coal catching on fire, iron rusting, sodium reacting with water, and digesting a pizza, right? When we eat a pizza, we can't get that pizza back. All right, that is everything you need to know for the matter unit of chemistry. Thank you so much for your time. Let me know if you have any questions in the comments below. Make sure to like and subscribe if you don't want to miss all my future videos. I'll be releasing a lot of chemistry content in the next couple weeks. If you're a teacher and you would like this exact PowerPoint, it is free on my TPT store called Chemistry Made Simple. I also have a study guide for this unit as well, available free on my store, and I have the entire year of chemistry. I hope you guys have a good day. Bye!